Okay, well, let's go ahead. And I'd like to welcome all of you to the Prairie Reconstruction Initiative Winter Webinar Series. This is the second of 3 presentations for 2026. My name is Jamie Ellis. I work as the Natural Areas Coordinator at the University of Illinois Urbana-Champaign, and I am part of the Prairie Reconstruction Initiative Advisory Team. The Prairie Reconstruction Initiative, here we go, is a community of prairie practitioners and researchers from more than 30 organizations with support from the U.S. Fish and Wildlife Service, working together to discover ways to improve the practice of prairie reconstruction. Our mission is to build an engaged community of practice who work together to overcome uncertainties through all phases of prairie reconstruction. We envision prairie reconstructions that are biologically diverse, ecologically functional, and resist invasion by non-native plants. We focus our activities on evidence-based tools and peer-to-peer learning. We developed a prairie reconstruction vegetation monitoring protocol and built a prairie reconstruction database that we maintain and continues to grow. By pooling and analyzing data from many reconstructions, we hope to reveal pivotal elements that will increase the likelihood all reconstructions meet expectations. Our learning opportunities include both in-person and online events where the PRI community can exchange experience and knowledge with each other. We believe these insights from both individual experiences and scientific investigation lead to our collective success. So during the presentation today, cameras and microphones will be turned off. So please type your questions and comments for the speaker in the chat or the Q&A function. Amanda McCulpin and I will keep an eye on those, and we will get to all the comments and questions at the end of the presentation. And this session is being recorded and will be available later on YouTube. So today I am very happy and pleased to introduce our speaker, Rachel Crownhart. She is a supervisor of natural resources for the Shakopee, Mdewakanton Sioux community in Prior Lake, Minnesota, where she works as an environmental scientist. She works primarily with wetland and prairie reconstructions, management, and monitoring. Working with a variety of plant communities is one of the highlights of her work, especially woodland spring ephemerals. She is most proud of a wetland reconstruction that turned a 40-acre row crop agricultural field into a pothole wetland complex with over 17 acres of restored wetlands. Impressive. A Minnesota state special concern carex species was recorded in this restoration as well. Yeah, and as a botanist, my ears always perk up when I hear carex. So today, Rachel will talk about her research and monitoring work, particularly the importance of prescribed fire on reconstructed tallgrass prairie. So I will stop sharing my screen. So Rachel, you can share your screen and the floor is yours.
All right. Thank you, Jamie, for that introduction. I will share my screen here.
Great. There it is. I see it.
Oh, okay. Again, my name's Rachel Crownhart, and like Jamie said, I work for the Shakopee Mdewakanton Sioux community in south central Minnesota, and I will refer to them as the SMSC during this presentation. And they're a sovereign tribal nation, And so what that means is they're responsible for the welfare and amenities of their people. So that includes housing, infrastructure, public works, family wellness services, public safety, and then they have our growing natural resources department. And that plays an important role in furthering their mission to be a good steward of the earth and a leader in environmental sustainability. And this is the approximate location of the SMSC's tribal land. And we're located in Scott County. And I've worked for SMSC for it's 9 years this month, actually.
Oh, wow.
And yeah, and we have a outstanding team on both. We have like land resources and then we have water resources side. And one unique aspect of our natural resource department is we try and do all of our reconstruction and restoration work in-house. So we have tractors, we have tillage equipment, we have the native seed planters, we have herbicide equipment. And so we have the opportunity to see a project through from start to finish. And then we get to observe that transformation of a healthy habitat where the plants and animals return almost immediately. And for me, that's the most rewarding part of my job, like the restoration that Jamie mentioned. It's amazing to see that when you bring the water back and the plants back, that the animals return, and it's wonderful to see. The land base for the SMSC is about 6,500 acres, and of that, there is 1,100 acres of reconstructed prairie, and that was all former agricultural fields. And we are located about 20 miles south of Minneapolis, so it's a very suburban area. And I will talk more about that and how that pertains to restoration and reconstruction, and then particularly burning in that sort of situation. So my main focus at work is prairie reconstructions, of course, and then wetland and forest restorations. And then we monitor those habitats, not only for plant species, but we monitor wildlife. We do breeding bird surveys, bird and bat monitoring. We do small mammal and herptile surveys, native pollinators, and wetland macroinvertebrates are some of the data that we're collecting in the summertime. And then we manage those different ecosystems with mowing. We do spot spraying. We collect seed and then redistribute it in areas that are lacking. And then most importantly, we use prescribed fire here at SMSC. So there we have northern prairie units and southern prairie units. And our northern prairie units are a little bit, they're our larger units. You can see these are the acreages that I have labeled here. This is our largest prairie, and this is where our bison herd is, and I will talk a little bit more about them in a little bit. And you can see here, there's a lot of infrastructure because this is the suburbs. So there's roads and there's houses and there's schools. And so when you think of smoke management, it's difficult, but it's doable in this situation, and we manage it pretty well. Well, we manage it very well when we're doing our prescribed burns. And then these are our southern units. They're a little bit smaller. This is that wetland restoration that was mentioned at the beginning. And this is a little bit less developed down here, so there's a little less restrictions when we're putting fire on the ground in some of these prairies. And so people will use these words interchangeably, which is fine, but when we refer to a reconstruction, it's basically starting from scratch. So there's no native vegetation left in this picture. It's just bare ground. Versus in this picture, I see some little blue stem, I see some switchgrass here, maybe some big blue in the background. So there's some native vegetation left. It's just highly degraded. And so that's how we distinguish a reconstruction from a restoration. And site preparation, I'm not going to talk about this a whole lot because I think most of the people on this call know how important it is, but this would be a perfect world if we were given a site like this to restore, because we could just plant it right back into prairie. But this is more of a realistic situation. This is what we would be given to reconstruct. So there's annual weeds in here and probably non-native, probably invasives. So we will start with a non-selective herbicide, usually glyphosate, and we will treat the area and let that die. And then we'll come through with our heavy equipment, our disc. And if there's any areas that didn't die from the first herbicide, we will come back and retreat that. And then we do our seeding in the fall, right before the ground freezes. We've also done some winter seedings as well. And this is our equipment to plant our native seed. And then because we're seeding in the fall, it's mimicking that natural cycle of freeze thaw that the native seeds would go through in nature. And so site prep, you don't want to shortchange any of your site prep because it will make your reconstruction a headache later on. So do it right the first time is kind of our motto. So fires on prairies, these were very common historically, and it was partly because of lightning, but more importantly, it was the anthropogenic burning that the Native Americans were doing for centuries. So after a burn, the grass resprouts almost immediately. 2 to 3 days, you'll start seeing green up. And so historically, this would have brought the bison herds into those recently burned areas. And this would have concentrated them in predictable locations. And that made hunting more efficient for the Dakota people. And they also recognized that prairies flourished after burns, and they understood the importance of fire to maintain the health of those ecosystems. The first burn at SMSC was back in 2003. It's the first time that they put fire on the ground here. We try to burn at a 3 to 4 year interval, and that's very weather dependent. As you saw, we have a very challenging urban interface, and we can't put smoke on roads. We can't put smoke on townhomes or houses or schools. And also our prairies are very healthy and they burn very hot. I've heard some people maybe don't have the most respect for a quote grass fire, but if they saw some of the fires that we have at SMSC, they would change their mind on grass fires not being very impressive because our prairies they burn very hot. And this is just another example. Like there's a large house back here and it's adjacent, it's right next to one of our prairies. So we use wind direction and wind speed and lighting techniques to make sure that the smoke is going in the right directions. And we are successful with our burns. This is not my research that I'm going to talk about today, but I did want to put a plug in for this because it's pretty cool to monitor fire effects. We set up 3 of these thermocouplers. It's these thin wires that you see in this picture, and they're connected to these metal rods, and they're connected to them at about half the vegetation height. So it depends on your prairie. And then one of the thermocoupler wires is placed on the soil surface below the vegetation. And then those thermocoupler wires are attached to our data logger, to these little outlets. And this is what the inside of the data logger looks like. There's a battery that we charge. This is where the data is collected and then it's stored on an SD card. And we charge these. And so those data loggers, we weed whip an area and we put them and we cover them with an old fire shelter and then with this metal bowl to protect them because we don't want them to burn for sure. And then as the flame front passes through the thermocoupler wires, the sensors record that high frequency temperature data. And then differences in flame arrival time are used to calculate rate and direction of spread. And then there's 2 other sets of these thermocouplers. You just can't see them in this picture. So after the fire goes through, this is what it would look like. So you can see some of this grass didn't even burn. So our data collector is safe. And then all that vegetation is burned up. Oh, and there's a QR code on the next page too, if you want more information on this. And then this is what, using our studio, we can create these graphs. And so the highest temperature was over 600 degrees Celsius, you can see here. And the gray line is the thermocoupler that was on the soil surface. And it just, you can see that that remained, it held its heat longer. It had a longer residency time, and the ones on those metal rods cooled off quite fast. So these temperature curves provide peak fire temperature and residence time, and then that allows us to quantify fire behavior and link the fire intensity and spread dynamics to vegetation responses that we're seeing in our prairies. And I cannot take credit for this research. This is my supervisor's work, Farron Davis Anderson. So if you have more in-depth questions, I will defer to her, but I wanted to mention it because I think it's pretty cool work that we're doing. And then I do want to talk quickly about our bison, because we sometimes get questions about them. We have 10 bison, 9 females and 1 male, and they were brought back in November of 23. And their prairie that they're in is 167 acres, and it's broken into 4 burn units. And so far we've burned 2 of those units since the reintroduction. And we have 2 vegetation surveys that we have completed in this prairie, and that was pre-bison. So we have nice baseline data. And then this summer is our 3rd vegetation survey that we will do in the bison prairie. And so we're looking forward to seeing that data and just how it has changed over the years. And I'm going to, this is a time lapse. So this is our bison prairie, and these are the bison back here, the little brown dots. And I'm not going to show you this whole thing, but this was our drone pilot, took this time lapse of one of our burns inside. So you can see the bison, they know to stay away from this fire, right? They evolved with this. They know, oh yeah, we should just chill until that's done. And you can just see some of the different lighting techniques to control your smoke. And we're not putting smoke on our organic recycling facility here. And we're keeping it off the road here. And we do have we have an internal lighter, so we're always cognizant of where they are on our burns. And this is just wrapping it up here. But see, no smoke on the road. This was a very good burn. I do want to just pause it here. And the bison, they were already coming towards this burned unit, and they're very curious. And as soon as that fire was out, they came into that blackened area, and they were so happy, and I got to experience this. I was very grateful for that. They were kicking up their hind legs, and some of them were rolling around in the ash. And it just was so cool to see them like reunited with what they would have known like historically. And then the fact that these are the Dakota relatives, and I was grateful to have been a part of that day. Okay, so for the data that I'm going to present to you, I did a master's at Montana State Bozeman, and my last semester I did a professional paper, and that's what this research was on. And I used the data that we've been collecting at SMSC. We started in 2019 using the Prairie Reconstruction Initiative vegetation protocol. So we had a really pretty robust data set that I was able to pull from and look at and compare these vegetation surveys across changes in time. So these were my 4 main objectives. And so all of the prairies in my study they have had 2 vegetation surveys done on them. And so I was comparing the first one to the second one and looking at changes. And some of the prairies had been burned between those surveys and some had not. So the ones that were unburned, I'm going to refer to as my control. And so I'm looking at species richness, how many species there are, alpha diversity, like how balanced is your community, percent native cover I looked at, and then I looked at vegetation height as well. And so my hypothesis was richness, diversity, and percent native would all increase in the burned prairies and either remains the same or decrease in the unburned prairies, the control. And then for vegetation height, my hypothesis was that it would be more it would be more based on site conditions and weather conditions more so than the fire. And I know I showed you a picture of all of our prairies earlier, but not all of our prairies have had 2 vegetation surveys. So they weren't all used in my study. So these were the ones that I did use. And this is that where our bison are again. And we use what's called a systematic grid sampling here at SMSC. And so the number of survey points in a prairie is based on how large it is, how many acres the prairie is. This prairie has 40. That's the total number that any prairie will have. And when we go to these survey points, we usually have 2 vegetation survey teams. And we have an iPad, and then we have a GPS unit that is Bluetooth connected to that iPad. And on a perfect day with no clouds, we get very good accuracy, like a half foot usually. And so we navigate to these points, and that's where we will complete our surveys. And then once we are done, we change the color of these dots in real time. And so if I'm in an adjacent prairie working with a team, I can see how far the other team got and vice versa. And I just thought I'd mention that because we find it very convenient here at SMSC, and it's just good for, remembering where we left off the next day, that sort of thing. So for the Prairie Reconstruction Initiative, their nested plot vegetation sampling protocol, I don't know that everyone uses it. So I'm going to explain it to everyone today, just so we're all on the same page. And like I think I mentioned, we do our prairies on a 3-year rotating basis for these vegetation protocols. And it uses a nested plot versus determining percent cover, because determining percent cover can be very subjective, especially when you have more than one survey team. And so this takes that guesswork out of it. And so instead of using percent cover, we're doing frequency instead. And so to build this, we built it out of PVC pipe. This is what it looks like in the field. And so we start with subplot A, and we identify all the species in subplot A, and they're recorded on the iPad. And then we move on to subplot B. And if there's any new species, that is recorded on the iPad, and C, D, and so on. To get subplot E, we flip the PVC on its long end to get that 5th subplot here. You can see. And so to calculate frequency, for example, if we found big blue stem in subplot A, it gets a frequency of 5 because it was found in all 5 subplots. Versus if we find New England aster, we didn't find it until subplot 5, then it has just a frequency of 1. And this is me and a coworker looking at some plants using this nested plot PVC frame. And if you see, you can remove the first 2 PVC pieces. And so you're not missing any plants. You're not covering up any of those species. And also I like to use those PVC pieces to poke at the grasses, and sometimes you have very thick thatch, and you can kind of spread it apart because you don't want to miss any of the little plants that might be hiding underneath there. And sometimes your vegetation is very tall and you can pick through it. So I find them very good use as little pokers as well. And then for my vegetation height, we use a row bell pole. And these are more commonly used to calculate plant biomass and grazing pressure indexes. So for stocking rates for cattle and bison. And we did use these on our bison prairie to calculate like how many bison we can have out there. And this is what I use to get the average plant height at each of those vegetation points. So each of these colors on this pole is a decimeter. And so you go 4 meters away from the pole and you read it 1 meter up. So this is a different angle here. So this rope is 4 meters long, and then this PVC is 1 meter high. So you have to kind of kneel down and you look at it from the top of this pole, and whichever decimeter segment is totally covered by vegetation is what you record. And then you do that in all 4 cardinal directions, and then it is the average of those 4 for each point to get your plant height. So for my data analysis, I did it all using RStudio, and I used a linear model. So to look at change over time, my treatment was my burned versus my control, which is the unburned. And so I was comparing the first surveys to the second vegetation survey. So there's a before and after, that's what that means. And then I also was looking at the interaction, which the linear model compares for me. And why the interaction is important is if there is an interaction, if it is significant, that tells me that the treatments changed differently over time. So something is affecting them and making them change differently versus if there was not a significant interaction, then the treatments were changing the same over time. They were both increasing or they were both decreasing. And I do have both situations that happened in my data. My species richness, so total number of plant species, these are my averages. And the burn, you can see it did increase after the burn. And my control, it did decrease on average. And so statistically speaking, so after our first vegetation survey, we compared the burned and unburned, and there was no difference. So we had a very nice baseline data. All the prairies were the same before. And then 3 years later, after the second vegetation survey, the controlled prairies where no fire was put down, they did decrease slightly, but it was not significant. The p-value was not significant. However, the burned prairies, after 3 years and a second vegetation survey, there was a moderate increase in the number of species with a p-value of 0.03. And there was a moderate interaction. So there was a p-value of 0.03. There was a moderate difference. So that indicates to me that changes over time differed between those treatments for species richness, which is consistent with an effect of prescribed fire. And this would support my hypothesis. This is just another way of looking at the species richness before and after. These are the control and these are the burned. And you might be thinking, well, Rachel, you had a lot more burned prairies. However, these are how many vegetation plots. So they were pretty similar. These just happen to be bigger prairies overall. And one particular one I want to point out to you, there was one prairie that we have actually done 3 times. So it shows up twice on here. And it's actually in Oak Savannah. It's the Shakopee Memorial Park. It is not owned by SMSC. We co-manage it with the city of Shakopee, and there's burial mounds there, so it's significant, very significant to the SMSC. And so here there is a large decrease in species richness, and between those two surveys, there was a large flush of buckthorn, and you all know how fast that invasive shrub can grow. So it really affected that species richness. At least that's what I'm going to partially attribute that to. But then if you look over here, this is also Shakopee Memorial, this very steep increase of species richness. So between these two surveys, we removed the buckthorn, we interseeded where that buckthorn was to try to get some native species to grow to outcompete that buckthorn, and we did a cultural burn. And I can't say that that was the only reason that there was that increase of richness, but that's a great indication that our management is helping and it's working. And as we gather more data from these prairies, it'll be exciting to compare years to years as Shakopee Memorial. In my professional paper, I didn't separate grasses and forbs for species richness, but it was suggested to me by someone. And so I went back into my R code and I did that. I separated grasses from the forbs or wildflowers. And I have read before that grasses don't change with fire, and they did not in our prairies. There was no change before or after the control or the burned. There was, after the burn, the distribution noticeably narrows, as you can see here. And so it becomes more uniform, meaning the grass communities looked more similar to each other after the burn. So maybe instead of some of the plots having 7 species and some had 2, now they all had 4. I don't know how that's ecologically important, but I just thought I would point that out. And maybe someone wants to comment about that in the discussion. But the forbs, on the other hand, forbs love fire. And there was a significant increase in the forbs in the burned prairies. And fire promotes diversity in those prairies. And this is well-documented response to burning, because burning it reduces your grass competition. It gets rid of that thatch that builds up on the ground. It opens up that bare ground for the forbs to reestablish. It gives more light to the ground, and it also warms up it allows the soil to warm up faster. I've read that in a paper before. And so the wildflowers really benefit from a burn. And I think we all know that fire is good. We all know that fire is good, right? It does great things. But when you see it in the data and when it comes up on your screen and it's statistically significant, I thought this was so cool, and I had to go get my coworkers and bring them into my office and show them. And I just love this stuff. I love when it shows you that you're doing the things right and it's making a difference. Alpha diversity, this is species richness, shows us how many species are present, and alpha diversity, it tells us how balanced is your community. So for example, maybe you have 50 species, which is pretty good, but if your prairie is 95% big bluestem, that's maybe not so great. So this is about balance and equality, and are all the species sharing together in your prairie. And the burned did increase in its alpha diversity, and the control did decrease, which was my hypothesis. And I used the Shannon's diversity index. That's what I calculated. And just like the richness, all the prairies after the first survey were the same. So I had another baseline data that was very good. There was no difference. And the control, again, there was a slight decrease, but it was not significant. And the burned, that had a moderate increase in the alpha diversity. And this also had a moderate interaction. So again, that indicates me that changes over time, the treatments differed from each other. And again, that would be consistent with a prescribed fire. And this is just a box plot showing the Shannon's diversity in my burned and my control, my unburned. And all these little dots, they are representing all of those different vegetation points. And then let's talk about vegetation height. So this is my box plot. If you take a peek, you see that it's increasing in both. And actually, to start out with, the burned, it was a little bit taller than the control, even to start with. It has a p-value of 0.03. But this one, there was not an interaction. So these treatments responded similarly over time. So it was contributed to something other than the prescribed burn. Something was making the vegetation height increase. And it does have a significant p-value. And my hypothesis of why that vegetation was both increasing was because of the severe drought that was in Minnesota in 21 and 22. And this green dot is SMSC and Scott County, and it was kind of low. It was concentrated here in Minnesota for those 2 years. And I just threw some numbers into my R code just to see how different it was statistically. So in 2021, when the drought started, there was a significant decrease in plant height. It has a very low p-value. And then in 2022, as the drought continued, there was no change in height. And even in 23, when the precipitation came back and we got out of that drought, it was so severe that the plants still did not recover in 2023. And then finally in 24, we see a significant increase. That's another very low p-value. And another increase in 25. Not quite as significant, but so I will be curious to see in 2026 if it levels out or if it increases even more. But that's most likely why. And then my percent native species. My hypothesis was not correct, which I was very surprised. They both decreased. I'm not surprised that the control decreased, the unburned prairie, but the fact that the burned prairie decreased, and even more so than the control. And I should say it was not significant. It was not statistically significant. It only had a p-value of 0.21. And there was no interaction between these treatments. So they changed the same. So here's my hypothesis of why this happened. And I would love to hear from people during the discussion to see if you agree or maybe I'm missing something. So with that drought, I know that there's prairie species that have a lower drought tolerance than others. And so perhaps they entered a phase of estivation where they rely on their underground reserves. So they're just using their stored roots or their tubers, and they're just chilling underground because there's not enough water. And I'm not even going to try to grow any vegetation above ground this year. And then they wait until that they have ample precipitation. And so when that happens, you have drought tolerant, drought loving plants such as Sidotes grama, Bouteloua curtipendula, who love drought. And I don't know if anyone else observed this in 2022, but there were vast areas of Sidotes grama. Like it loved the drought. and it was doing what it should, right? Because the other plants, they couldn't grow. So it's like, I got you guys. I'm going to fill this in, and, until the water comes back, and then you guys can come back. And so perhaps that is where the native plants went. They were just dormant for a number of years. And so maybe this year we would see that native percent increase as those less drought tolerant species rebounded and they came back, and then it reduced the drought tolerant plants such as the Cytoxgrama. That's what I got for a hypothesis for you. Take it or leave it. I don't know. Let's talk about it. So some of my takeaways, I know that the richness and alpha diversity, it was not a significant decline in the control. However, if we continue to remove fire from those ecosystems, I think you would most likely continue to see a degradation in number of species and alpha diversity in those prairies. And the percent native cover, I know I just gave you my hypothesis, but a possible different research that I would like to do is comparing a brand new prairie reconstruction. So after 4 growing seasons is usually when we do our first burn on our prairie reconstructions. And I would like to do a vegetation survey the growing season before the burn, and then another one after the burn, just to see how much the native percentage increases, because fire eliminates so many non-native fire intolerant plants. And I think it would be interesting to see that change. And vegetation height, I think that's more dependent on your site, your soil, your environmental conditions as a whole. And our prairies, I mean, 82% native. I might maybe be bragging, but that's pretty nice prairie. That's pretty good prairie. And so sometimes maybe if you have a really healthy prairie like that, the only way to really increase your species richness and your diversity is by interseeding. So you're bringing seeds in from other areas. So maybe you have prairies on your land that have certain seeds. So you're collecting them and putting them in other prairies, or maybe you're buying seeds, or maybe you're working with another agency and you're doing a seed exchange. But because our prairies are so segmented from each other, unfortunately, they can't really seed each other like they would have done historically. So we need to help them by interseeding. And because my study, it represents one post-treatment time point, it's a short-term response, right? So long-term monitoring will allow us to determine whether these fire-driven patterns are sustained. So we will continue our vegetation surveys here at SMSC using the nested plot protocol, and hopefully our data will continue to support that understanding of the fire ecology, and will continue to capture the importance and the ecological benefits of fire with these ecosystems. So I hope that you have found that these results reinforce that when we monitor consistently and apply fire intentionally, that we really can see measurable ecological responses, not only in data like we saw in this presentation, but on the landscape when we're walking through our amazing prairies. And remember that all of this supports the goals of long-term prairie resilience, which we are all after. Thank you. And I'll take any questions.
Great. Thank you so very much, Rachel. We do have there's a couple questions in the chat. Owen asks, what time of year were you burning?
In the time lapse, in the time lapse picture, or
Well, I think I'll add to that. Yeah, I'm just curious about the timing of all of your burns. Are you shooting for
general?
just in general, just dormant season burns, or in the spring, or in the fall, or other times of the year? When do you guys generally burn?
We do spring burning and we do fall burning, and we try to change up. If a prairie was burned in the spring, and the next time we'll shoot for a fall burn. And so we just try to give as much variety to the prairies as we can. We would love to do a growing season burn, but just it so far it hasn't worked here for a number of reasons, and a lot of maybe smoke mitigation has a lot to do with that, because I've never actually done a growing season burn, but I hear they're very smoky. Yes.
Yes, yes, they are. Okay, great. Thank you. What else? I'm getting back to my the chat here. I went ahead and unmuted and or allow. If you would like to ask your question directly, you have access to the cameras and microphones now. So Amanda asked, how many years after the burn did you do the after vegetation survey? And did that vary across sites?
That's a good question. That it de it depends, and that was not calculated into my research, but it was something that me and my advisor had talked about. Like it could be something to consider for further research. It's like, yeah, how many years between burns is this vegetation survey? But that was not part of what I was looking at. Because it could have, for example, we could have done a survey in the summer, and we could have burned that prairie in the fall, and then it wouldn't have been re-surveyed for 2 years. So if that answers the question.
Yeah, and then but on average, how when you were doing the after veg surveys, about on average, how long was it after the burns for each of those units across the
It
units, I guess.
it would have been it would have been no more than 3 years.
Ah, okay.
Yeah. Yeah, between 1 and 3 years.
Okay. Great. Great. Yeah, thinking of the response of the vegetation response and, looking at the richness and diversity and seeing some significance from those burn um treatments. Um do you think that there's adding species? Were you getting new species, or also were you just in your sampling protocols? Do you think that there was more evenness of the species? You think some of um, those less common or harder to detect species, maybe they were filling in spaces, or what do you think was happening with the response of the plants when you were seeing that, a little bit increase in richness and that increase in diversity? What do you think was happening there?
I think that because it's the forbs that's increasing,
Mm-hmm.
and I think that those grasses are so aggressive, and they make so much thatch that the forbs eventually aren't getting enough sunlight, and so if they can't get enough sunlight, then they know they're not going to be able to produce a flower. So then they're going to go dormant. So after that burn, when there is ample light, then I think they sprout, they regrow. And so I think that they're there. I think they're in the seed bank. If they're perennial, I think they're just waiting for the right conditions to be able to regrow and flower. That's my hypothesis versus like a brand new seed sprouting. I shouldn't say that though, because we do interseed. One of my coworkers, they collect a lot of seed and then put it in other prairies that are lacking certain species. So that could have something to do with it as well.
Okay. Yeah, that was going to be, actually, I was going to ask that first. What other management activities are you doing on these prairies that might affect the vegetation, or doing invasive species management, or removing species, and it just sounds like you answered that you are doing some interseeding. Is that right?
Mm-hmm. Yep, we're doing interseeding. And we do invasive species management, and we'll do like spot mowing if needed. We're trying to get away from using herbicide if possible. So that's kind of our goal, is not using that if we can help it. And so, but interseeding is been our latest management that we've been working on.
Okay. Yeah, I'll be, I think we're all curious to hear the results of that, see the results of that. Yeah, one of our speakers last year, Andrew Call, does some research on that, so folks can look up our YouTube channel and see what he had to say with some of his research. What other questions or comments do folks have? We still got a few minutes here, so go ahead and unmute yourself or type those into the chat.
Hey, Rachel, this is Amanda. I'll start. I just, I loved the sleuthing that you did about like the drought and how that might have differentially affected the different prairies. And so like it occurred to me like it might be interesting to graph instead of just like before after, but have like the years somehow, and then they wouldn't line up exactly right, but you'd have the start point and the end point at different points, and then you could kind of show what time when the burn was, and it wouldn't, I mean, I don't know, like it wouldn't necessarily affect your statistics, but in terms of visualizing what happened, I thought that might be an interesting place for you to go.
In terms of the drought, or the when we're burning versus the vegetation survey?
I think just in general, like, because as you pointed out, the year, there is a year effect because of the drought, but there's also, there's other aspects of weather that, that are different in different years, whether it's like it was super warm or it was cold, or you have a late freeze or something. And sometimes like it's kind of seeing a more complete version of the data where you have on the horizontal axis is like the year, and then each prairie starts in a different year, right? Because that's what I understood, is that the beginning survey was not all the same year, and the ending survey was not all the same year. Yeah.
Correct. Yep.
Okay.
Yeah.
I just thought that might be interesting to look at.
Yeah. It's a good suggestion. Thanks, Amanda. There's a lot you can do. There's so much you can do with the data.
Any other questions for Rachel? In the chat, I put a link to our webinars page on the PRI website, where you can check out our webinar that's coming up, one more next Wednesday, March 11th. And then also links to our past webinars, including one delivered by Farron Davis Anderson last year, and that's on YouTube. And Rachel mentioned some of Farron's research in a presentation. And so go check that out. And there's nothing else, anything else? Rachel, thank you so very much for your time.
Of course.
And presentation and inspiration of the work that you do at up there in Minnesota. Look forward to maybe in a few years hearing updates
Of
about
course. Yeah.
the work that you're doing.
Thank you for having me. Appreciate it.
Okay, everybody, that wraps up today, and maybe I'll see you next week. So take care and have a good day. Bye.
See ya. Bye, Jamie.